to use the compound interest formula to solve financial problems. And the formula is the following. It is the amount equal to the principal times the quantity to the n t power of 1 plus r over n. And these items have obvious meanings, such as A for amount and P for principal. R is going to be the rate. N shows up twice in the formula, and N stands for compounded. How many times this is going to be compounded? Is it going to be monthly, quarterly, daily? And then you'll have T, which is obvious. That is time. Okay, so we'll go look at the first example. This example, you don't know the amount. So it's going to be a straightforward problem. Nothing to solve for except basic calculations, and you get an answer. So A we don't know, and the principal is going to be 3,000. And the rate is 4.25%. It will be compounded quarterly. And the amount of time we're looking at will be 10 years. Okay, so just set it up. You're going to have A equals 3,000 times the quantity to the 10 times the quarterly number. If I'm compounding something quarterly, how many times is it compounded? 4. So that means once every 3 months in a year. If I'm doing it every 3 months, that's quarterly, so you're doing it 4 times. And then we'll have 1 plus the rate, which is going to be 0.0425. And then divide by n, which again is 4. The order in which you have to do this in your calculator, and I'll highlight in yellow as I go along. The first thing you're going to do is this, and more specifically inside of that, you're going to do this first. So do 0.0425 and then divide by 4. You should get 0.010625 and add 1 to that. So you're going to come up with this so far. A equals 3,000, and it's times 1.010625. And don't forget we have the 40th power outside there. 10 times 4 is 40. So leaving that answer in your calculator, hit the caret symbol and then type in 40. Hit enter, and you come back with 3,000 times 1.526 and on out. I'm not going to write the whole thing. And leaving that number in your calculator, hit times and then 30. And you're going to come back with the following. Not times 30, times 3,000. So I'll go back and put 2 more zeros on that. That makes a difference. I wondered why we only have $45. This is 13. No, it's actually 137,354. That's a very ugly looking comma. And then 85 cents. So we went from one extreme to another. Clearly that's not the right answer because I had a problem with my calculator. The answer variable was changed when I hit second enter. It should be 4,578 and 50 cents. Alright, for this problem we have an amount that we're looking for. The principal is 37,000. And we're going to have a rate of 3.6%. it will be compounded every 6 months. And the time period is going to be 12 years. Compounded every 6 months. Set up the problem first, and we will have A equals 37,000 times the quantity to the 12 times 2 power, since it will be compounded twice each year, and that'll be the quantity of 1 plus 0.036, awful looking handwriting, over 2. So the first thing we're going to do is the inside of the problem. So it'll be 0.036 divided by 2 and then plus 1. That comes out to be a small decimal comparison to what we're used to having, 1.018, and that's to the 24th power. That's what we do next. And to the 24th power, that's a little larger number, 1.428, and it goes out for quite a bit. I'm beginning to wonder why I use lined paper on this iPad if I never stay within the lines. And then multiply by, it should be 37,000, there we go. Well, this is really getting ugly. And times 37,000 is going to be 52,863 and 67 cents. The answer to this problem should be in this example, first and foremost, I'm going to try to stay within the lines. And we have an amount that is $60,000 to start with. The principal we have no clue about, and then the rate is going to be 5.5%. It will be compounded daily. And the time period we're talking about is going to be 6 months. A couple of things to look at in this case when you're setting up the problem. First, we'll start with 60,000 and actually put 4 zeros to represent 60,000. And then set that equal to P, we don't know. And then 1 plus 0.055 over, and it's compounded daily. So if it's compounded daily, what is that for 1 year's time? 365. And then the time period is 6 months. What is that in relation to a year? A half, yes, it would be half. So I need half of 365. I don't know if I have enough room to write this, so I'm just going to zoom in and do this. We'll have 0.5 to represent the 6 months time period, and then 365 for the compounding variable, which is n. Now if I lower this enough, zoom out to where it all shows up, that'll work out fine. Okay. Well, really, I can zoom back in and do this. That'll be better. Help me to stay within the lines. All right, so the step 1 that we're going to have to do here is this part. Now we can see all of it. It's going to be inside the parentheses, so do 0.055 divided by 365 and come up with a really small number, which I'm not even going to write on the screen. And then add 1 to it. And that one's a little easier to come up with. That would be 1.00015, and it keeps going out. We need to take that to the 0.5 times 365 power. And of course we still have P and then the 60,000 out here. So leaving the number in your calculator, hit the caret, left-hand parenthesis, 0.5 times 365. And you should come out with a number that is approximately 1.00015. 0, 2, 7, 8, and on out. And we'll keep our 60,000 here. Now we have to divide the 60,000 by 1.0278 and whatever the rest of it was, and set that equal to P. So this number here should still be in your calculator. So type 60,000 divided by second negative sign, and then you'll have an answer of 58,372.60, which is 60 cents. That is your final answer. In this example, we have an amount which is $7,000. We have a principal which is $3,000. We have a rate which is 4%. And it is compounded. We'll make this quarterly. And the time is what we don't know. We have to solve for that. So set up the problem as 7,000 equals 3,000 times the quantity to the 0.04, not the 0.04, but the quarterly times time, power. Quarterly is 4, and time we don't know, so that's T. 1 plus, and then we'll have our rate 0.04 divided by n, the quarterly amount, which is 4. Now I can zoom in and hopefully write better from now on. Okay, so we can still do inside the parentheses first. So do 0.04 divided by 4, and then add 1. That's easy enough to write out. 1.01. And then we still have the 4t power, 3,000, and then the 7,000. Now, get rid of the 3,000 from the right by dividing by 3,000. So on the left we have 7,000 divided by 3,000. And I don't know how that got in there. Just white out. There we go. White out. And equals, I don't know why it's doing that. It's just an awful day for bloopers. I can't take the blame for this. It's just doing it on its own. So there we go. We'll try this again. Equal sign. And then 1.01 to the power of 4t. So now we need the log natural of both sides. Or actually you can just do log. You can use a common log. So log of 7,000 divided by 3,000. And then log of 1.01 to the 4t power. Now, by rule, you can move this down to the left. So we'll do that. Log 7,000. That's really not working well at all. I'm going to try to up the size of the marker a little bit, see if that helps. 7, no. We'll try a higher marker. How about this? There we go. 7. It just doesn't want to go. That's an ugly 7,000. It's just not working well at all. So we'll do 4t and then log of 1.01. Okay. Well, what we can do now is to get rid of this on this side. So on the left, we're going to have probably not enough room to finish this out. I hope we do. But we'll have log 7,000 divided by 3,000. And then we want to have this, log 1.01. We're dividing by log 1.01. And then we can also jump to the next step because we have a 4 there. we can include that 4 over there when we divide. And that'll leave t by itself, and just barely enough room to write the final answer once we do these calculations. You should come out with a value that is 21.3 if we round to the 10th place, and that represents years.